For the ones who do have laptop, they can connect to the Academy lab. We would be starting the lab shortly. If you have not registered through the APNIC portal, you would have to create your login details, and then you would be able to connect to the Academy page. Has everybody launched the website? The web page of the APNIC Academy? Let me guide you through that. On the event page, if you are going to go scroll down to the course material, you would be seeing the session details, the timings and all the stuff. The day one, we already have covered this day one and all the sessions. For the day two, we are going to start off with this exercise. You can see the link here. If you click it on the link, you'd be redirected to this page. Make sure that you are logged in. Let me log in. Once you are redirected to this page, you are going to go to the first lab, MPLS, LDP and SR lab. You need to launch it. You'd be provided with a prompt. Just click in yes. And make sure that your pop-ups are not blocked. It's going to take a little bit of while to load the lab. Meanwhile, if anybody is having some issues with logging in, you can just raise your hand. The virtual labs take a little bit of time because it boots up real virtual router machines on which the devices are present. Once you have been logged in to the lab, you can see that on the right hand pane we do have the instructions that we are going to follow throughout this lab. For the left hand side, we have an Ubuntu machine where we can see there are 6 routers. We have the telnet session for every router, and again, if you are going to go and do it in one session, it's preferred to do it in one session. But if you are having a break, you need to take a break, you can go into the menu and save the lab whenever you like. It would be saved for next 7 days. Whenever you come back to this lab, it would be saved, your configuration would be saved. But after those 7 days, it would be eradicated from the machines. So make sure that you come back on time. Just as Imtiaz told you guys, we'll be doing part 1 and part 2 for this session as at the moment. The topology that we are going to follow for this one would be something like this. We have 6 routers, router 1, 2 and 3, they are connected. Whereas router 2, 3, 4 and 5, they are also connected in the full mesh connectivity. The router 4, 5 and 6, they are on the right hand side. You can see the IP assignment, whereas the interfaces as well for all the routers. You can, if you see in the blue shaded comments, we can see that the loopbacks are being configured with the IP scheme of 172.16. There is a IP scheme. If you go to the link between router 1 and router 2, you can see that the IP scheme is 10.1.2.0. That means that the first router, that is the router 1, and the second router, the third octet would be the second router. That means the connectivity between router 1 and router 2 would be 10.1.2.0/24, and the last octet being the name of the router. That means the router 1 would be configured with .1, whereas the router 2 would be configured with .2. Same pattern would be followed for the other router and the other connectivities as well. For example, we can see that the connectivity between router 4 and router 6, it is 10.4.6.0/24, whereas the IP that is configured on router 4 would be .4 and on the router 6 would be .6. Whereas for the loopbacks, we have 172.16.1.x. For x, we can take the name of the router. For example, the loopback of router 3 would be 172.16.1.3, and for 4, it would be 172.16.1.4, and so on. Make sure that you have this topology readily available to you when you are doing the lab for further references. Just as I mentioned to you, the IP assignment for the loopbacks, they are also being provided here for the easiness, whereas for the links between router 1 and router 2, the IP block, whereas the IP addresses, they both are also mentioned here. And again, saving the lab, just like Imtiaz said, it's a lengthy lab. We would be doing all the parts of this lab in consecutive sessions. So please save the lab once you are done with these sessions that I would be following. And it's preferred to do it along with me, so that you can, if you have any questions in between, you can come in and ask the questions. Alright, the first part of this lab would be the MPLS LDP. In this, we are going to configure the MPLS LDP protocol. There's a little bit of change in the instructions that we are going to be following. We are not going to follow the Academy lab instructions. Rather, we would be doing this one. Let me open this. It's present on the course material of the page. You can go and refresh the page just to enable this link. Once it's done, then you will be redirected to this page. So yeah, the IP scheme for this remains the same, just as I mentioned before, and the point-to-point IPs, they are also the same. Lab instruction saving guidelines, and okay. All right. We'd be configuring, for the instructions. If you are gonna go side by side, you can go into the menu of the page and split the windows. In that case, you would be provided with another window for the instructions. You can minimize that and expand this one on the half of your screen, so that the both the instructions and the configurational pane would be side by side. All right. The steps that we are going to complete in this section would be, we will be configuring the label range for the MPLS. We would be enabling LDP, as just mentioned in the theory just a moment before, that there are three kind of the type of configurations that we are going to do, that we can do in the MPLS. That could be the LDP, whereas the RSPP, traffic engineering, TE, and the BGP. For this part, we would just be doing the enabling the LDP over the routers, so that the tags that are gonna be going through the routers, that are being done through dynamically. So after that, we'll be setting a router ID, enabling the LDP on all the relevant interfaces, so that those interfaces could be in the MPLS protocol. And after that, we'd be verifying the configurations. Initially, whenever you are going to go to a router, it would be asking for a username and password. The username and password for all the routers here mentioned would be Cisco. Just because these are the Cisco routers, it's just default route username and password. All right. For the first configuration, we are going to go to the router 1. Is it visible to you guys, or should I increase the font for the CLI? Yeah. Okay. For the instructions for the router 1 that we are going to configure here would be for the interface 0.0/0/0/0. We are going to do a no IP v4 address. We are going to change the interface into two sub interfaces. That would be the .10 and .11, and we're going to run the OSPF in the .10 interface. Let's go on and start off with configuration. Just like if I have started off with the router number 2, if I go and see the instructions on the router number 2, we can see that by pressing the enter, you are going to go and enable the username Cisco, and the password is the same. You can see that we are in now. Okay, for the router 1, let's start off with the configurations. Actually, at the moment, the interface 0/0/0/0 is already been configured with the IP address that I have already showed you on the. Just let me show you the topology again. This was the topology. This interface that was configured on router 1 with a .1 IP with the route 2, that is being changed from a single interface to a sub interface. We are configuring a sub interface with a .10, and we are going to create a sub interface 20 as well. Okay, once the interfaces are being configured, we are going to go and put that interface in the OSPF configuration. For that, we are go into the router OSPF instance 1. Area would be 0.5 gigabit Ethernet. Now, if you are going to see at the screen, is the commands visible to you from behind? I hope they are. Let me drag it a little bit up so that all the commands that I am typing are visible to you all. Okay, what we have done here is we have changed the interface that was 0/0/0/0 into the two sub interfaces 0/0/0/0 .10 and .20, and after that we have added the .10 interface into the OSPF configuration so that it could be included in the OSPF process. Before getting out of the commit, the config, we are going to commit it so that the changes are written onto the router. Once we are done with that, we are going to show IP interface brief. We can see from here that we have configured loopback 172.16.1.1 in the state app, whereas the interfaces .10 we have an assigned IP. The assigned IP is the same, 10.1.2.1, and the interface 0.0/0/0/1 that is configured with the router 3. It has an IP of 10.1.3.1. Okay. Now, actually, we are going to go and put in the range of the labels, MPLS labels that we are going to configure with the config T MPLS label range table 0. Now here, what this command is actually doing is enabling the MPLS label with the range of 24,000 to 24,999, and the table that it's going to save these labels would be table number 0. Once we are done with this, we are going to go and assign this router with the initiate the MPLS LDP. To initiate that, we are going to type in MPLS LDP and provide the router ID, which is the loopback of this router. Once we are done with this, the MPLS LDP is enabled on the router, but we have to add the interfaces into it so that those interfaces are involved in this process. We have included both the interfaces 0/0/0/0 and 1, and we are gonna exit it by commit. At this point, we have configured the LDP on the router number 1. There was a little bit of change in the interfaces from the Academy lab, but other things that are all the same. As we have the connectivity of router 1 with router 2, and we have created a sub interface on the router 1, then we are going to go and create a sub interface on the router 2 as well. Initiate router number 2. If you type and enter, you would be how to? Oh, okay, all right. If you want to paste all these configuration at a single time, you can just go and grab the commands, copy the text, And in the Academy, you have a lightning button on the top left. You're going to click on that. On the type text, and on the third option we have type clipboard text. There would be a clipboard that will be shown to you. You can paste all this here, but due to the issues with the PDF, we don't have the spacing correctly. So unfortunately, we are gonna not do that. I'll just go and let me try with these 3 lines only. No, actually when you copy it from some text that has the indentation correctly, it would be shown like something like this. So whenever you're going to paste it here and you are going to type OK, then it would be typed inside the CLI at the same time. So just to do that, in this again we are going to change the IP address for the interface 0/0/0/0, and we are going to make 2 sub interfaces. Let me type in, no worries, gigabit .10. Encapsulation would be .1q, and the IPv4 address would be 10.1.2.2/14. Interface gigabit is 0.0.20. Okay. Encapsulation is .1q. IPv4 address is 10.10.10./24. Once we are done with both the sub interfaces, we are going to put them in the OSPF function. OSPF router OSPF1. Yeah, would be 00. Interface gigabit and interface this is the configuration for creating the sub interfaces and adding them to the router OSPF1. We can commit these configurations, after which we are going to go and configure the MPLS labels as well as the MPLS LDP over this router. Terminal. MPLS label range table is 0. 999. MPLS LDP is enabled. For this router, the router ID will be 172.16.1.2. On the router 1. Yeah, actually this is what we are doing. We are adding, let me open the topology here for you. When we, just like OSPF, when we are configuring the OSPF, we have to enable all the interfaces that are being connected with that specific router. On this router, we have 2 interfaces. The one is gigabit 0/0/0/0, and which is connected to the R2, and the other one is the 0/0/0/1 that is connected to R3. So whenever we are enabling any dynamic protocol, we include all the interfaces into that. So this is what the command is doing here. When we see it here, that the interface gigabit 0/0/0/0 and 0/0/0/1, we didn't do any changes on gigabit interface 1. We only did the changes on the 0. We made 2 interfaces, but those interfaces come under the umbrella of 0. Yeah, enter the interfaces. Once we have entered the interfaces, this commit command, what this commit command does is commits all the changes to the to be executed. It writes on the file. So after that, you can commit it, and once you have committed it, it might ask you for if you are sure you are going to commit it or not. Then you can type yes, and then it's good to go. If you can see on the configuration that whenever I type in some command, we go into a hierarchy. For example, here we have config, whereas whenever we go into some instance, just like the MPLS LDP, we are inside config and the MPLS LDP. Once I type in root, I would go to the initial config. I go all the steps back from the configuration, so I can commit it. Everything in that would be committed. If you are going to commit on a specific instance, then only that specific instance would be committed. That's why it's basically based on the Juniper. If you are familiar with Juniper syntax, it gives this. This is probably the Cisco iOS XR. This is the XR that asks for the commit. Yeah. Okay, we were on router number 2. We have defined the labels. We are in the MPLS LDP. We have defined the router ID at the moment. We haven't defined the interfaces yet, so I'll go back in the MPLS LDP and define all the interfaces. Sure. 3. Can anybody tell me why we do have interfaces 0, 1, 2, 3 on router 2 rather than just 0 and 1? Yeah, exactly. If we see at the topology, the router 2 is connected with 1, 3, 4, 5. So we have interface 0, 1, 2 and 3. So that's why we are enabling all the interfaces in the MPLS LDP protocol. Once we are done with it, we can थर्ड में बनाया सेगमेंट राउटिंग के साथ कॉन्फ़िगर करेंगे इस वजह से और अभी आप तो इसमें तो Moving on to the router number 3, we are going to do the same thing. Config T. Now with this MPLS label configuration, where I have defined a label range of 24,000 to 24,999. Does anyone have a question regarding what this range is? Why am I defining 24,000 specifically? Does anybody know that? The number of possible would be the range in between. I could have given 26,000 to 26,999. This is because it would be conflicting with the segment routing labels. That's why we are going to use a different range here. After that, we would be going into the MPLS LDP, enabling that. Router ID for 1.3. Exit. Moving on to the router number 4. Interface gigabit 10. Encapsulation is 1Q. IP address. Now on the router 4, if we go back to the topology, we can see that we have router 4 connected to router 6. Here also we are going to do a sub-interface configuration. We are not going to configure anything on the 0/0/0/0. We are going to do it on 0.10 and 20, just as we did for the router number 10. So for the first .10, I have given the IP address of 10.4.6.4/24, and for the other one, interface gigabit 0.20, we would be having encapsulation .1Q and no IPv4 address. And again, once the interface configuration is done, we are going to go into the router OSPF instance and add those interfaces in the OSPF. No interface gigabit. And once we are done with it, we are going to go out and commit. This was for the sub-interface configuration and the OS and enabling them on the OSPF. Now we are going to go and configure the MPLS labels as well as the MPLS LDP. (24.999) and the MPLS LDP, including the router ID 16.1.4. Again, we have 4 interfaces on this router: gigabit 0, 1, 2, and interface number 3. Here, commit the configuration and exit or end it. Now for the router number 5, username and password. For router number 5, we are gonna do the basic configuration of just the MPLS labels as well as the MPLS LDP. We don't have any sub interfaces for router number 5 or 3. Config terminal MPLS, label the range of it and table number 0, the range 24,000 and 24,999. MPLS LDP. Router ID is the loopback address of router number 5. interface gigabit 0 as well as interface 1, 2 and interface number 3. Once we are committed for the router number 5, we are done with the configuration, and finally on the router number 6. As we have configured sub interfaces over the router number 4 and its connectivity is with router number 6, we are going to configure sub interfaces on router number 6 as well. Interface gigabit. First of all, we are going to remove the IP address from the giga interface 0. No IPv4 address and interface gigabit, creating the sub interface number 10, encapsulation 1Q, and assigning back the IP address to the sub interface. Interface gigabit Ethernet, sub interface number 20, encapsulation .1Q, and no IPv4 address on this. Once we have configured sub interfaces, we are going to add it into the router OSPF instance number 1. The whole topology is in area number 0, so that's why we have area number 0 configured here. No interface. We are going to remove the first gigabit Ethernet interface 0 and replace it with the gigabit Ethernet interface .10. Once we are committed with that, then we will be configuring the MPLS label range. The table is 0, 2400, 44999. After the label table, we enable the MPLS LDP, and router ID would be the loopback address 16.1.6, and both the interfaces gigabit 0 and gigabit 1 would be added into the MPLS LDP. This is the first part of this lab where we have configured all the interfaces. We have running OSPF throughout this topology, and we have also configured the MPLS label and the MPLS LDP with all the interfaces and the router IDs. The next part of this lab would be to configure the layer 3 VPN configuration. For that, we are going to go on the PE1 router. So based on the topology, we can see that the router 1 here on the farther left hand and the router number 6, these both are the PE routers, and let's see if they are able to ping each other or connect with each other. Let's go on the router number 1 first. So now if we can see on the screen that we are going to ping from the router 1 to router 6 loopback, and we can see that it's successfully reachable through all this topology. If we are going to go onto the trace for this 172.16.1.6, we can see that the first hop that the packet is taking is 10.1.2.2. If we go to the topology and check it, 10.1.2.2 is the router 2's gigabit 0 interface. The next IP that we are seeing on the trace route is 10.244. This is the IP address of the segment from router 2 to router 4. And then the last one, we are seeing that 10.4.6.6, which shows us that the path taken by this packet would be from router 1 to router 2, router 2 to router 4, and from router 4 it's connecting to router number 6. This is the path that the packet is taking. Now for the PE1, that is the router number 1, we are going to go and configure the L3 VPN configuration. For this we are going to go and in the config mode create a VRF with the VPNA, assign the address family for this VPN for the VRF, cast, export route target 100:10 and import route target, that is 100:10. Once we have configured this VRF, we are going to go and assign the IPs on two interfaces that we already configured on router number 1 and router number 6, where we didn't have the IP addresses. We didn't configure the IP addresses on them, but now we are going to go and configure the IP addresses on them. For the first one, we are going to go in the router 1's .20 interface, .20. We are going to assign the VRF and the IP address for this. .10.10.10.1 255.255.0, and we are going to shut the interface as well. Once we are committed with the changes, we can see the show IP interface brief. We can see that now we have configured the IP address on .20 interface as well. But a thing that is need to be mentioned here is we are having the VRF name on the right hand column. We can see that all the interfaces are in the default mode, or default VRF, whereas only .20 is in the VPN A. This is the name of the VRF that we just created for the router 1. Once this is done, we are going to go and configure the BGP with the ASN number 100 over the router 1. For that, we are going to go into the config mode, get into the router BGP instance. Address family for this one would be VPN v4 because we are using the v4 IP address. The neighbor that we are going to create on this one is address family neighbor. The neighbor IP would be, if you see at the topology says that the R1 and R6 are the PE routers. So we are going to create the BGP between R1 and R6 directly. So for that purpose, the neighbor that we are going to define here would be the loopback address of router number 6. As it's reachable, we would be having the reachability of router 6 from router number 1. We are going to assign the remote AS, that is 100, and it's in the neighbor 172.16.1.6. Update source would be the loopback. Showing its update. Enable this remote AS. We are in the remote AS and the neighbor configuration. 72.16.1.6. Dash source. When you are going to configure the BGP, there is a little typo in the instructions where we have the update source. You are going to go and type in update dash source. A dash is missing here. So just to clarify that, loopback 0, and we have added it. Address family would be VPN for unicast. Once we are done with that, we are going to go and mention the VRF into the router as well. That's BGP, VRF. We created VPNA, VRF by the name of VPNA. We are going to define the address family IPv4 unicast and redistribute static. Exit, exit, exit. So if may I have your attention just for a moment, what we just did here is we created a VRF with the name of the VPNA. After creating the VRF, we defined its address family to be IPv4. The export target, route target, as well as the import route target, we have defined the values of 100:10 for both of them. After that, we are going to do the interface configuration. We have put a no IPv4 address beforehand when we were configuring the gigabit interface 0.10. We add the IP address there, but not for the .20. For the .20, we are going to add the VRF in the interface beforehand, and then we are going to configure the IP address for this interface. Once we are done with this, we are going to go and configure a BGP. The BGP AS for this configuration would be the 100, router BGP 100. The address family defined here would be the VPNv4 unicast, as we are using IPv4 addresses. The neighbor that is defined here is 172.16.1.6. That is the loopback IP address of router number 6 as per the topology. The remote AS is 100. We have configured our own AS as 100 as well as the remote AS as 100. That means that we are configuring and internally we are having a BGP configuration for both the router 1 and router 6. Update source loopback, what this does is that it provides the neighbor IP of the loopback for configuration over the BGP. Again, we are going to define the address family as the VPN4. Once we are done with this, we are going to go into the top hierarchy of the router BGP100, configure the VRF VPN with the name of VPN-A that we just configured on the config mode. We are going to RD value for this would be 100.1, whereas the address family again we have IPv4. The redistribute static would do whatever routes in static we define on this router, it would be redistributed in the BGP, and that is the basic configuration that we are doing for the L3 VPN. Now to go to the PE number 2, it would be router number 6. Okay. For the route number 6, I will go and configure in the router number 6, start off with the router BGP configuration. Config T, route BGP 100. The address family again would be VPN v4 with unicast. The neighbor would be 172.16.1.1, which is the loopback IP address of router number 1. Update dash source loopback 0 and address family VPN v4 unicast. Once we are done with this, we are going to go into the BGP hierarchy in the top and define the VRF for VPN-A. D would be 101, same as what we configured for the router number 1. Address family is IPv4 unicast, and we redistribute static. This was the BGP configuration that we did on router number 6. After this, we are going to configure the VPN. Alright, for the VRF VPN-A, we are going to define the address family of IPv4 unicast, the export route target, same as we defined in router number 1. Route target, okay, it's colon, and import route target 100:10. And we are going to configure the interface as well. We are going to go up in the hierarchy and interface gigabit 020. Okay. V4 address and define the VRF for this one, VPN-A, and then the IP address, IP IP address 20.20.20.1.55. No shutdown. Keep the interface up. Exit. Commit. All right. Once we are done with this configuration, we would be seeing in the instructions. If you see that we have this configuration done, the route BGP 100 and the address family, the neighbor that has been defined. These are the configurations by the neighbor IP. You can see that these configurations are for the router number 1 because its neighbor is router number 6, and we also have the VRF configuration as this address family IPv4, and the import route target and export route target are 110. We are gonna maybe that's because we have configured the BGP before and initiated VRF.
Remove the IP address from the sub interface and then actually configure it under the VRF. Because if you have already IP address, then it actually does not allow you to configure the sub interface under the VRF. So we have to do in 2 steps. So if you are seeing this error, because there is an error in configuration, it will not allow you to commit the configuration. So you can just exit it, Control C, it will exit. And we will again check the show run VRF. You can see there is no VRF. So one way is we can first create the VRF. So if you need to check the configuration for a specific section, this is how you can do it. Show run router BGP, and it will show us the BGP configuration. Since the previous configuration was not taken due to the error, so I will try to do it again. I will go to the config T, configuration mode. Can you just copy and commit? Control V. ओके, so ये हमने कहाँ से सिलेक्ट किया? हमने तो config T नहीं. Copy text, Control V. Okay, if it is like this, then you can adjust it manually. You can see I have to do router BGP, then address family IPv4, VPN v4 unicast, then neighbor, update source. Actually, due to the PDF, it is sometime it can happen like this. Loopback 0, then address family, then again I have to go to the router BGP protocol level, and under that I need to configure the VRF, address family, okay, VPN v4, RD will be under it, and then the redistribute will come on the next line. What else we have? So let's first commit this part. We can show just to see what change we are doing. you can do a route to just go to the top level, and then it will show you what you are adding. Then if we want to see commit, there is a way to see the error, commit show errors, so it will show you if there are any errors. BGP directed warning neighbor does not exist, has no remote AS defined. So actually it's saying whatever the configuration you are adding, you need to add the remote AS number, because if you do not add the remote AS number, router will not be able to know like what is the it's iBGP session or eBGP session. So we need to go back to the BGP level, router BGP, so on the neighbor, against the neighbor we need to specify the remote AS number. Yeah, you can see remote AS number. Here you need to specify AS100. So if you do again check the show, so you can see we have added this remote AS number 100. Similarly, you can adjust the configuration in your case as well. Now try to commit and see if it accepts it or not. So now this time it has accepted it. So I will update the configuration instruction just to remove this error, but you can try to adjust this error.
Once this configuration is done at this part, it's requested to save your configurations, because we have reached 12:30. Yeah. Yeah, complete. This part's completed. Yeah. Okay. Okay, for the BGP, we have done the BGP and the neighbor and the VRF. We are just gonna create the VRF again. Yeah, from here onwards, VRF, VPNA, the address family, IPv4 with the unicast, and the export route target is 100:10. And the import route target is 100:10. Once we have committed this, we are gonna go and change the IP address for .20 interface as well. Interface gigabit 0/0/0/0/0.20. No IP address. I think we don't have an IP address already configured there. We are gonna define the VRF, VPNA, and IP address. Address 220.20.20.155.0 and a no shut. We are going to commit the changes at the end. Once we are done with this, we are going to check, verify that if the configurations are implemented. We can see that the configuration for the interface 0.20, we have the IP address of 20.20.20.1 and it is under the VPNA. Now if we are gonna ping it simply, if we are gonna go and ping from router 6 to router 1, let me just open router 1 as well. Show Cisco and show IP interface brief. Now we are going to do a simple ping. First let's do a simple ping.